Okay, so this is our second video here in the product sum section, and it's going to be a pretty quick video simply because it's just going to go through the practice and review problems. So you can see they're all finished. My advice, if you haven't already, is pause the video and solve these questions first, right? This is good practice. I know we already did number 4 in the first video, but everything else here, I think it's worth your while to take a pause and then solve as many as you can, and then come back and look at the solutions. And so for that first problem, it's just recognizing, I have a difference of two trig functions, right? Difference of two signs that I don't really know too much about either of them. But if I combine them, I might know something about them. And so when you look at your product to sum, it's one of the very first ones. Actually, it's the second one, right? So it's that second one right here. The difference of two sine functions could be 2 times sine of the difference of the angles over 2 times cosine of the sum of the angles over 2. And so, wow, I'm just going crazy there. So when you do that, you get 30 degrees and 135, and yeah, those are much more manageable. And so you substitute and solve, and you should get a final answer of negative root 2 over 2. Now, question 2 is just that's part of the review part. Like, that's not anything new in terms of a product of sum, but we sort of have to recognize that this is cosine of 2 theta, because any time you have an inverse trig function, so this part right here, that whole expression really represents your theta. So it's asking you to find cosine of 2 theta. So I drew theta. It's since it's a positive ratio, I know it's a 9:2 ratio in the first quadrant. And notice that I didn't even bother solving for the missing leg. I mean, I could have easily done 81 minus 4 to get square root of 77. So I could have done that. But I chose the cosine double angle formula. I chose the one that only involved sine. So again, I'm thinking of it in terms of efficiency. I don't have to solve for that missing side. And so then when I complete the problem, 2/9 squared, that's 4 over 81, times 2 is 8 over 81, and then 1 minus that should get 73 over 81. Okay, number 3. We've seen questions like this before, where it initially looks sort of complex, but this green thing here, that's an angle. Call it alpha. This blue thing right here, that's an angle. Call it beta. And again, I know those are angles because of the inverse notation. So this is really, let's find cosine of alpha minus beta. Cosine of alpha plus beta. So that's cosine minus sine. And then I drew my beta over here. I know it's quadrant 2 because that's where cosine, when it's a negative ratio, that's where that would live. And then I know tangent, when it's negative, is in quadrant 4. So I can label it appropriately. Add up the angles, and we should get 33 out of 65. It's funny because I feel like I've seen this number multiple times in this unit, and that's mostly because we look at a lot of 3, 4, 5 triangles and 5, 12, 13 triangles. Okay, we already did number 4 in the first video, so let's jump down to number 5. Similar question, like sine of 2 theta. So I have the expansion of what sine of 2 theta is, and how do we draw theta? Oh man, I noticed that this is like, how many times have I done this? I don't need both that notation. I must just be cutting and pasting it. Anyway, sorry, side note editorial. We draw a cosine ratio negative in quadrant 2, negative 2 to 3, and we get a missing length of root 5. So then when we expand it, we should get 2 times root 5 over 3 times negative 2 over root 3. Okay, now number 6, this hypothetical if, right? Oops, sorry. So we're looking for a product of two angles that we really don't know nothing about, but now we're starting to get a little familiar with this kind of format. I know that 38 minus 8 is 30, so there's probably some method to the madness here, right? And 38 plus 8 is 46. So that's the whole reason why you were given 3/4. Just be careful. It's given to be cosine is 3/4, so adjacent to hypotenuse. Don't accidentally or inadvertently call that 5. It's not a 3, 4, 5 triangle unless the hypotenuse is the 5. And then notice that the formula specifically asks for sine of 46, not cosine of 46. So I have to adjust it slightly and write that as root 7 over 4 plus 1/2, because that's what the sine of 30 is. And we can simplify that to get root 7 plus 2 all over 8. And then our last question, number 7, there might be more than one way to solve this. Like, for example, I know cosine of 75. Well, 75 is half of 150, and 15 is half of 30. Or you could say 15 is 45 minus 30, right? So there might be multiple ways to solve this problem. But maybe the most efficient way is to realize that the difference of two cosine functions could be rewritten using this formula here. And so when you take the sum and divide by 2, you get 45 degrees. When you take the difference and divide by 2, you get sine of 30 degrees. And so do be careful. It is, I think, the only one that has a negative in the coefficient. And so therefore you get negative square root of 2 minus 2. Okay, so hopefully that made sense. And like I said, the idea was maybe to have solved them first and then gone back and looked through the solution, and hopefully that's exactly what you did.